Morning, or not present here. I'm Nandhini, working as an assistant professor in SNS College of Engineering at the Department of Computer Science and Technology. Today, we are going to see a topic on structural aspects of IoT. What do we know on what is the structural aspects of IoT? There are some issues related to structural aspects of IoTs. Then it comes under an environmental structure, graphical characteristics, scalability, interoperability, security, and privacy, and open architecture. These are some structural aspects. In the structural aspects, and diagram has been represented with the help of this structural aspects of an IoT, which categorizes the above characteristics I have been dictated. And thus, first one is an environmental characteristics. Mostly it comes under an M2M, that is known as a machine-to-machine node, having a design constraints. Second point is we can say that it consists of a low power, which means it runs in a less potential in a low battery manner. And the third point is it consists of a low cost, so we can easily affordable it. And the fourth point is significantly more devices than land environment are being used here. Next is an severely limited code of RAM. RAM we are using much less. Then requirement coding is MAC, IP, and anything else needed to execute in this embedded systems. It consists of 32-bit memory and 8-bit microprocessor. Next one comes under a example is an using gestures and an interaction, physical words, etc. We are using it. Next one is a requirement for simple wireless communication technology, which we use an IEEE standard of 802.15.4 standards, which is very promising for lower layers. This consists of an environmental characteristics. Next one we are going to see is an traffical characteristics. In a graphical characteristics, we are going to see some types of networks or an application. The first one is, for example, a cellular mobile networks are designed for human. For human only, it is designed for what it is designed to communicate with each other, which is a centric one. It easily used to interact and communicate with the people. So between humans, a data communication involves web browsing, file downloads, and as soon as possible, we are exchanging images, videos, audios, files, documents, many things we are easily interacting with the human to human persons with the help of these mobiles and etc. Next one is cellular mobile networks are, which it is in graphical characteristics because we are using human to human, which is used for communication. So it is a graphical constraint. Next point is in the M2M, we are expecting many three to many devices there. Long intervals and transactions and small messages, these are all we are communicating with human to human. Requires an device energy which is effectively a para-mounted one, which is effectively a para-mounted one. And here is an one properties and requirements of machine-to-machine application. What it been used here? We are using mobility, message size, traffic pattern, device density, latency requirements, power efficiency requirements, reliability, security requirements. These are all we are using. Where we are using these are in ITS, e-healthcare, surveillances, and smart meters. The mobility is used in vehicular ITS. In e-health, we are using it as an pedestrian vehicles, and surveillance and the smart meters, we are not using it. Then message type size traffic pattern. We are using it in a medium regular or irregular manner, same as in e-health. And in server lines, we are using in a larger regular manners, and smart mode meters, we are using in small regardings. Then device density is high. In e-health, it is medium, and in surveillance, it is low. And in smart motors, it is very high, up to 10,000 per cells. Latency, it is very high. In e-health, it is medium. In surveillance, it is medium. In smart motors, it is very low. Power efficiency, ITS, it is low. In e-health, it is high. Surveillance, it is low. And smart meters, it is high. Next one is a reliability. It is high in ITS, e-health, and in smart meters, but it is medium in surveillances. Second is security. It is very high in ITS and e-health, medium in surveillances, and smart meters, it is very high. Next one, what is known as a scalability? Generally, what we will say it is as scalability. The application which is used for a long time, scalable, which long last for us, it's known as a scalability. Then, which we use to built on before deployment technologies we need to do is in the system with the help of protocol without having any systems or start from scratches. If we have no systems, we need to start from the scratches. Next one is a larger system, better than the efficiency of a smaller system, meant by a scale. This is known as a scalability. This is known as a scalability. Then interoperability. In the application technologies we use to supply for the stakeholders, which is used to develop a core set of common standards. Next one is possible of extending standards may provide cost efficiency. Interoperability is mainly providing a cost efficiency. Next one, security and privacy. IoT related to electric power distributions, good distributions, traffic and transport management, health, and other key applications as paused last earlier. It is critical to maintain the system widely confidential, identity integrated, and trustworthiness. Then, in an open structure, goal is to support a wide range of application which is used to common infrastructures, preferably based on a service-oriented architectures defined on the top of a physical infrastructures. These are been we are using. The reference of an IoT is being given in a YouTube video. Thank you.